Okay, 10 people are there. Very good. I'll go to the desktop now. Now I got this icon for installation of 32-bit and 64-bit. I have chosen the 64-bit with admin running mode. So that's why it is asking me before running it. Okay, after opening it, when you go for the fresh installation, you will not get this type of look. You will get blank here. So in that project manager, you have to go to first project, and here you can see that different type of things are there. Okay, so as I told you, in the help, you will get license manager. Okay, this is the license manager. From there also you can look at the file if you forget or if you get any problem in licensing that software. Then so after installing license, it will give you all type of access to this software. And then when you click it for the first time, go to the file. After going to file, you will get these things: new project, open project. Okay. In my case, I am trying to open the project, but it is not opening. But you can go to the new project, obviously. And after going to new project, okay, it will open the new blank project. So I will just show that demo later on, because in my machine some problems are there. So I will just show you in existing project how to add the new file. Okay, so just neglect this file shift register. As you go for the new project, it will show you that this type of device is there, which is again selected by the wizard. And in that I have to go for the source. Okay, or project. In project I can go to new source. Here I will just click the new source, and when I click new source, it will go to the window where I am getting a different type of new source. So in this project, actually we are dealing with the VHDL language. That's why I have to choose the VHDL module. Okay, after choosing VHDL module, I will just check with the name of that weld module, and it should not have spaces or some special character like that. You just simply take a your name or something like that. I will take and get test. Okay, the test and test. So just simple name I am taking and test. After that, you have to click it add to project. Okay, when I click it add to project, it will add it automatically add to this project, which is open right now. So I will go to the next. When I go to next, it will showing me the window for adding the input output ports or input output in out ports. It is showing the name of entity, name of architecture. Here I can change the name of architecture also. Okay, so I will write here and ARCH. Okay, so it will just change the name of that architecture. By default, it is taking behavioral. After that, I will just click here A input port, then B input port. Okay, then C as a output port. So for making it output, you have to select here and make it out. Okay, if you want to use the buses, okay, multiple lines of A port, 4-bit, 8-bit, then you have to click it bus, and then you have to give MSB LSB from 0 to 8 or 0 to 7 or something like that. I will take simple example for AND gate with A, B input and C as the output. All of you hearing me? Can you see the Xilinx software now?
Yes, sir.
Okay, thank you. So with this, I will go for the next thing. This is what the wizard actually. By using this wizard, your work is very simple. You don't have to write the library addition, and you don't have to go for the entity writing, entity body writing. Okay, only you have to concentrate on the architecture part, as we have discussed in many times in the PPTs. So I will just show you what is happening here. So it is showing me what type of design you are selected. Okay, name of that design, then architecture name of that design, then ports information. Okay, so it is showing me input port for A and B and output for the C. So this is what I have selected from the wizard that is shown at last. And when I click it finish, at the end, you will get this type of ready-made file created for your design. Okay, now you can see that by default it is taking the library IEEE and use of the package IEEE standard logic 1164. After getting this complete file, these are commented information. You can neglect, just delete it. Okay, so that it will be very small code for you to understand. Okay, it will look very simple and small then. Now in entity you can see that very simple name of entity we have chosen and test. Okay, after that and test name declaration we are writing the port information. It is generated by wizard only. So this is what the syntax for writing the port information A, B, and information about the input output nature of that port. Then type of the port, it can be bit type also, it can be standard logic type. So by default, it is taking the standard logic. Okay, and after that bracket complete, and at last you have to put the semicolon. But in between the A, B, and C, there are the semicolons. You can see at last there is no semicolon. After completion of the bracket, the semicolon is put in. It is for the closing the statement of port. Okay, this port statement is closed here. Okay, then for entity closing, the complete entity closing, the semicolon is used. In most of the cases, semicolons are used for the stopping the statements in this language. After that, architecture is there. The architecture name and architecture is taken by the wizard as I suggested for that. Then it is taking the name of entity by default, because for the same entity it is designing the architecture. That's why you can see that entity name mentioned here is and test. Okay, and the architecture name is and architecture. So after that it is giving you begin, and in begin your job starts. Now in begin, very simple job we are going to do. We are going to make an AND gate. I will just write C less than equal to, that is called as signal assignment. Okay, but most of the time students understand that less than equal to, this is called as signal assignment statement. So A and B. Okay, after that semicolon, bus finish. This is my AND gate in the VHDL language. Means I have to type only one language for AND gate program. The rest of the things are done by the wizard itself. I think up till this you understood. Okay, I will just click this line. Okay, because I am getting two different lines here. Okay, so the first line is for the first VHDL file, which is for AND gate. Another is for shift register. So you can see that in the first line, when I click it, it is showing me .vhd extension file. Okay, here it is written in VHD. This is the file type for the particular VHDL file. The extension of file is .vhd only. So when I click it, I will getting this file open. When I click this shift register, it will open the shift register file. So by clicking it, you can open your code. Okay, or if it is already open, it will show it to you. Okay, when I click the particular file. So when I click it and get, it will opening the and get file or make it visible to you. After that, I want to go for the next stages of design flow. As we have seen in the first unit, there is design flow, there is multiple steps for getting the file downloaded into the design, okay, or into the IFPG or CPLD. For getting the bit file at the last in that design flow, we should go for the synthesis. So before synthesis, we'll go for one thing that is called a check syntax. जैसे आप लोग C में syntax check करते हो, the same way here you are checking the syntax. So I will just first save the file. Okay, water changes I have done to all these files open in this project can be saved with one click. Okay, after saving it, you can save the single file also, or you can save the all files also. I will just put save all. After saving all, I will just click here. Okay, design utilities. In design utilities for the selected file. Okay, if it is not selected, it will show something different. But if it is for this, it is showing me that design utility, and after that check syntax. I will just click check syntax here. After check syntax, I am getting that message, process check syntax completed successfully. If by mistake I have not written something which is in the syntax, by default I have taken something wrong statement, so you will see that it will not work for the check syntax. Again, it is asking that something is changed. You save the file first and go for the check syntax. And now you can see that some error will be coming here. It will show, I think, that AN is not defined or something like that. Actually, I pressed wrong button. Actually, it is doing for both the files. I have to again select it for this one, and I will check syntax. I think I click run all. So you can see that check syntax failed. Okay. In this language, it is very simple to identify the errors. Here it is showing that line 16 is having the unexpected character or unexpected identifier. Okay, so you can see that unexpected identifier is and. Okay, so it is basically a keyword, but it is not printed clearly or typed clearly. That's why it is having this problem. When I make it correct, so it will just remove that error, and it will show the completed check syntax successfully. Okay, the check syntax completed successfully message is shown. After getting this message, we have to go for the next stage. Now for going to next stage, what we have to do, we have to go for the design utilities. Okay, and you can have the simulation for this uh, design. Okay, for simulation, I have to click here. There are actually two tabs present. First is your implementation, and another is your simulation. Okay, so by just changing this tab, I can go to simulation mode. So I have selected and get file here only for implementation, and for simulation also I am selecting the and get file. Okay, and test. After selection of this and clicking this simulate behavioral model, I will go to the next window, or that next tool is actually opening. So you can see that Xilinx tool is here, and this is iSIM. Again, this is same tool, same company is having the same tool, but this is somewhat different tool than the apparent tool chain. Okay, so this is simulator for the waveforms. That's why it is invoking in another window. So you can see that whatever inputs mentioned in the VHDL file, that those are visible here, A, B, and the output C. Okay. Now by clicking this input here or here, you can give the input to this A and B. So I will just click here, right click it, and go to the force constant. After making force constant, I can go to the value of 0 and 1 assignment in this window. So I will just make it 0 here. Okay, then I will go to apply. Okay, now 0 is applied to A. The same way I can change B here also. Okay, or I will go to OK, and then I will select B. After that, I will click it, right click it, and go to force constant. In force constant, again, I will make it 0. After making it 0, I will say apply. After applying these two as a 0, I have to run the simulation. So I have two choices for running: run all and run in step. So in this run step, I will just click the run step, and you will see that I am getting some green lines out of that. I will just show the significance of those lines. When I click this button, I will get total window coverage for the signals or simulation waveforms. So here you can see that I can zoom in, zoom out for the waveforms. So here you can see that initially it is having the orange color. Okay, so it is a basically undefined stage. Okay, it is not defined one or undefined, you can say. So it is initially showing that U. Okay, U means it is one of the simulation level in the 9-value logic. In 9-value logic, we have seen that undefined condition is there, don't care condition is there, weak one, weak high, okay, strong one, strong high, strong zero. So that 9-value logic is actually implemented in this simulation tool. So initially it is having the U. When I click on this area, it is showing me the 0 value. So by changing this cursor or marker, I can check the particular value at particular instance. Okay. Now I want to test the functionality of AND gate. Now I will just change the B to 1. Just go to right click, force constant, then make it 1, apply, okay. Then it is showing me in next run that B is changed to 1. Now I can click here and I can check the status of that A, B, and C. Now it is showing that 0, 1, 0. Obviously, AND gate is giving me the 0 for this 0, 1 input. Again, I have to check the A. Then when I make it 1, it should give me output as a 1. So when I apply it and run it, I will get output as a 1 only. Okay, you can see it is working very nicely for AND gate. The same thing are actually shown here also in command mode. Okay, here you can see how the values are changed, how the values are assigned. That is shown here. Okay, the A is assigned with A1. That is shown here. Again, on if you go to upper side, it is showing that B is assigned to 1. Then it is showing by default it is to 0. Okay, so all these things are actually recorded in the command mode on the console. The same thing is shown here in the console also, and graphically you can view the rest of the things here. So when I make it again, change some value of A or B, so I will get the changes. Okay, and when I make it say 0, again for next run, it will make the output 0. So you can see that it is working as per your AND gate. So this is not big job actually, but for starting, you should do this practical. After that, I will just finish this by closing the window. Okay, if you want, you can save this window also. But there are a lot of facility for saving and all that. You can have the image also for saving. So this is what your first project for the VHDL language. Is it possible to do for all AND gate? ऋषभ,
येस सर.
करता येईल?
हो, पण
Yes.
सर नेट खूप कमी आहे, त्याच्यामुळे 3 दिवस तरी लागतील डाउनलोड करायला.
No, don't do that. 3 दिवसात काय होणार नाही, त्यात एरर येईल. So you please go to your friend somewhere else who is having this direct downloading installation and
हा.
get it copied. असं डाउनलोड करू नको. ज्याला 1 दिवसाच्या वरती लागेल असं इन्स्टॉलेशन तू घेतलं ना, तर
हा.
डाउनलोड मॅनेजर जर वापरला तर ऍटलीस्ट होईल तरी बरोबर. पण डाउनलोड मॅनेजर जर नसेल तर त्यात
हा.
मोस्टली एरर्स येतात, बरेचसे प्रॉब्लेम येतात, कनेक्शन ब्रेक होतो बरेचदा. तर ती
हा.
लिंक चालत पण नाही आणि ते इन्स्टॉलेशन कामाचं पण नसतं बरेचदा. तर
हा.
you go to somewhere who is having the broadband connection or
हा.
directly get the installation file because it is 6 to 7 GB, I think.
येस.
Okay, so then after, yes,
7 to 8 GB, sir.
7 GB, na? Yes, yes. So this is what the basic practical of your you can say first assignment. After that, as we are discussed in our regular practicals, okay, I have shown you the schematic for the shift register. So before closing this project, actually, I will show you how to create new project in later. But before that, just before closing the shift register, I will show you the shift register or how the shift register is looking like. So this shift register, as we have discussed a lot many times, it is there in the manual also. You can see that in our manual as I shown in the PPT also. So this is my shift register. So this is the shift register which is having the serial in left in also, along with this reset clock and data in and select buttons. So here you can see that main entity which is having these inputs: clock, reset, data in, select, serial in, left in, and serial right in. Okay. So these are actually the inputs, and this is what the output of this shift register data out. And by forming this, we have done this practical. Okay, so theoretically we have understood this practical by using the case statement. You are able to select the output on the temp, and after final that the temp is declared as a data out. Okay, that is final output of the entity. So how it is doing when the case statement is select line is 00, then for 00 of the select lines it is choosing the data in as a input. Okay, the data in as a input selected, and it is loaded into the temp register. After that, temp register is coming to the data out. Means it is doing the parallel in, parallel out function for 1 1. When it is for 0 1, select line, when select line is 0 1, it is taking the 3 bits of the original temp, okay, or the previous temp, and after that 1 bit is added to from the serial left in. Okay, so in this case, left in is taken as a input, and it is added to the previous 3 bits of the temp. So this way you can have the shifting of the input on each clock edge, because this program runs on the clock edge. Okay, for each clock edge it will run, this loop will be run, and for each clock edge it will change the output or shift the output by 1. okay, for left shift or right shift. You can say for 10 it is again taking the temp as an input, okay, and in the temp the data is loaded like this, serial in on the left side, and after that 3 bits of original temp. Okay, so these 4 bits are actually formed with the help of this concatenation operator. You can see that their concatenation operator is there. By using this concatenation operator, you are binding this 3 plus 1 bit and you are loading that into the temp. After that, temp is taken as a data out and it is showing you the output. This output is looking like this. Okay, so I am not able to rotate it, I think. This is not possible in this. So you can see that this I will show you in the simulation actually. You can see that the clock edge is shown here. The clock is running with high frequency, and when I change the inputs, according to that, the output is changing. So this type of stepping or shifting is occurring on the lines. The LSB is getting that one first, then second bit of the LSB after LSB. LSB it is giving. After that, it is going to the next bit, and then at the MSB. You can see the one is shifting from the serial input line. This type of simulation we can do with the help of Xilinx. So I will show directly that code. The same code I have copy pasted here. Okay. So it is expected to write this code from you people. So you go for the wizard, and in wizard you select the input output ports like this. Okay. After that you will get these all things ready made up to this begin. Okay, this part you will get by the software only. No need to write this. After that, process statement you have to write. Okay, but in process statement you have to mention these entities, say input lines, which are actually which is a 4 bit, that is called as temp. After that, this if statement for reset condition, when the reset is 1, the output should be 0. And after that, if it is not 0, then go for this else if. When it is going to else if, it is always checking for the clock edge, and on each clock edge, this case statement will be run. Okay, and when the rising edge is selected, clock tick event and clock equal to 1, it is taking the select line status. As per the select line status, whether it is 1 1 or 0 1 or something else, it is doing the action as per this routine return. So you can see that when others condition for others, okay, other than these 3 condition, it is giving you the null operation. Null operation means it is not doing any action. The previous option or previous data stored in the temp remains as it is, and after that case statement is ended and if statement is ended, and after that the final data is locked into the output lines of the shift register. I think this is I am explaining for second time. So we'll just go for the simulation of this shift register. I will just click here simulation. Before that, again you have to go for the check syntax of the shift register also. Okay, after getting into the shift register, so in you have to click for the simulation. When you click for the simulation, again you have to check for the right name of the file. Okay, in project you can have multiple file, hundreds of file can be there. Out of that, which file you want to simulate, that you have to click. Then after clicking it, go for the simulation behavioral model, then click it run. Okay, so now you can see that the same input outputs are shown here. So for clock, for this is a somewhat critical simulation for understanding. If you know the code, then and then you are able to simulate this code. So in the very first, I have to click here, and instead of force constant, I will just click force clock. Okay, you don't have to say force constant, because force constant gives you 0 or 1, but I want continuous clock on this input. That's why I will take force clock, and after getting force clock, the leading value and trailing value I have to mention. So I will just give leading value 1 and trailing value 0, means it is having the change of 0 1 1 0 1 0 like that. After that, I will not mention any offset here. I will just mention the duty cycle of, by default it is taking 50%. I will get a square row, and I have to mention the speed of the clock. So I will take 10 nanosecond. Okay, if I write 10, so by default it is taking 10 nanosecond. After that, I will say apply and OK. So now you can simply see that is the clock applied or not. So here it is showing that, okay, in the console that clock is applied. But if you want to see it physically on the simulation tool, you can see that here it is showing the clock For getting it clearly, you have to click this button, zoom to full view. Okay, after clicking it, you will see that there is a clock shown. But for getting the clear picture of the clock, you go to the zoom button, and when you press it multiple times, you can see that 10 nanosecond clock. Okay, so here you can see that clock period. If you check the period for one clock cycle, it is just changing by the 10 nanosecond. Okay, 290 to 300, or 300 to, you can say, 310. So it is coming to say 10 nanosecond. So by using this, you can have the clock assignment. After clock assignment, I will go to the next force value. So this is what the reset. In the reset, I will just click force constant and make it 0 first, because the reset is actually active high here. I will just assign first 0. I will run it. Okay, for a small duration. After small duration, I will just change it to 1. Again, I will change it by force constant with 1. Apply it. Okay, then okay. Then again, I will just run it. Okay, so for getting total view, I will click like this, and I can see that when I make it reset 1, the output is default given 000, because I have mentioned it in the program. You can see in my program I have mentioned that condition. When the reset is 1, the temp output is 000. Okay, then that temp is given to the data out. That's why it is coming as 0. You can see. So simulation tool same showing whatever you are written in the code. At next stage, what I will do for the next check of the operation, I will check this condition for one of the select line, whether the data in temp line is coming as an output or not. For that condition, what I had to do, I had to give data to the data line. Okay, I will just force it with the constant again. So I will take simple pattern 1010 for 4-bit and I'll make it apply. After making it apply, it should get that all data locked in. But before that, I will just click the select line status force constant, and for getting first operation, I will select 1 1. It depends on you how you write the code. If you can take 0 0 for that also. Okay. Now I will not check the serial in serial left. I will just check the simulation for the parallel loading of the data, parallel in, parallel out. I will just run the simulation. Now you can see that it is showing something here. So for that, I will click here and get the complete view. And after that, when I'm getting the view, I will go to this area. Okay, and then I will click zoom here. Okay, after zooming it, it is making clear picture what is happening here. Now you can see that for the first stage, okay, the data out is coming like this, but you can see that our output is not changing. Why it is not changing? As the reset is actually at 1 position, because it is in the reset position only, but then it is not taking the input data to be reflected on the output. So I have to make it 0 for the normal operation. Now what I will do, make it 0 for the normal operation. And as soon as I make it and I run the simulation, I will get the required changes at the output. Now can you see that whatever is the input, okay, that 1010 is coming as a output for the 1 1 condition of the select line. Is it?
Yes, sir.
Okay, yeah, thank you. So then I can change these values to 0 1 and 1 0 condition for getting the serial in and all that. So I will check that condition also, but before that, I will just change the data in after this. So that will be one condition to understand. So I will make it all 1 1 1. Okay, all 1, apply. Okay, run the simulation. So it will give me all ones at the output. You can say the output is changed here. Now I will go to the another area, that is in shift register condition, actual shifting of the data. I will simulate this condition. For 0 1, I have to give the input to the SL in. Okay, the SL in will be my out input for the condition of 0 1. I will make the select line 0 1 first, force constant, then 0 1, Okay, by using this, I am selecting the SL in. So for SL in, if I give the data force constant 1, okay, I will select 1, apply. Then I will do one thing. No, I have to actually use 0, because what is happening if I make it 1, not it is already 1, so it will show same thing. So that's why I have to change it to 0. It will be more effective for watching. I will make it 0 first, and then I can go for 1 also. So by making this again, I will go for the simulation, and you can see that here the data is changed to 000 when the select line status is changed. Now you can see the shifting of the data as your original shift register. Here I had to zoom it for multiple times, then and then you are able to see it. When the clock is getting clear, at that stage only you are able to see that changeover. This stage. I want to get this condition after 1010 to 1111. Okay, for getting this condition, I have to just shift it. Okay, here you can see that condition. So here you can see that the shifting of the data. Okay. It's taking too much time. Uh, Actually, I want this instance, not a local instance. Now you can see that this shifting is there. Okay, so if you make it more zoom, it will show you that on one clock edge it is shifting. Yes, so here it is making clear picture of that. So now you can see this is very small changeover because the clock frequency is very high, 10 nanosecond. So you can see that at 10 nanosecond it is showing like this, and the one clock edge, the first input is changed, or LSB, MSB, LSB is changed. After that, second bit is changed, then third bit is changed, and then fourth bit is changed. So this is why your shift register is taking the input in from the left in. Okay, so the left in is taken as a input as 0, and that 0 is reflected on the LSB first, then MS, after that second bit, third bit, and the MSB. Likewise, you can have the change of this left input to 1 also. I will just make it constant 1. Okay, apply it. After that, again run it. at last I will get this changeover. Here also you can see that changes. So again I will zoom it. Yeah, now it is remains steady. You can see that one is first given to the LSB, then second bit, third bit, and fourth bit. So this is how we have to see the simulation. Okay. There is another one thing also in the simulation. If you want to observe the radix basically in the ALU operation, you can directly click here and you can change the radix of this. Radix is what you can see. Normally, you are watching the binary signals. You can have the hexadecimal at unsigned decimal also. So now, by unsigned decimal, it is possible to get the directly view on the decimal numbers 1, 3, 7. But in the ALU, it is required. That's why I told you. So this type of simulation you can do for all the rest of the conditions for this shift register. This is what the manual test bench, you can say manual testing of the waveforms. There is another way of testing is that test bench approach. But before that, I will show you how to make a new project, and after that we'll go for the ALU simulation. This is what you are about the shift register and basic AND gate. I will go for a new project first. This software is actually giving me the problem. That's why I not close this. So when I click new project, okay, so it is asking me the project wizard. So in wizard, I will just go for the ALU test. Okay, ALU test will be the name of my new project. Again, it will ask for the path and all that description. So you don't go for anything. You just select the path you want for your hard drive. After that, next, then you have to select the device. Okay, the water devices available in our lab actually that we have to choose because that device should be downloaded. Okay, that design should be downloaded into that particular device. While synthesizing, it is taking reference of these devices. Okay, by default, you can take any device for simulation purpose. Okay, the simulation doesn't have any role of the devices. It is just making the speed constraint changes. But when you go for downloading, if you choose something else and if you're downloading on particular another device, it will not work. Okay, it will not accept also. So what you have to do first, you select the device. Okay, in our college library, in college kits, we are having this Spartan 3E. Okay, and in this Spartan 3E, we have the Spartan 3S 250E. So this is what the name of this IC. It is having the 250K gate capacity. Okay, Spartan 3 series and 250K gate capacity, and this is PQ208 package, means plastic cord 208 pin with the speed grade of -5. Then in the next line, it is asking you the synthesis tool. So by default, you have to take XST, that is Xilinx synthesis tool. If you have any third-party tool installed in your machine, that and you can select that particular tool from this. So there are actually commercial tool available other than the Xilinx synthesis tool like Leonardo or Simplify. So those are actually the industry leaders, Simplify and Leonardo. Those are actually for commercial use. The people are using those one. Then next is your simulator. In simulator, you have again choice. These are actually not installed, but many times people are using the model sim software. This is again leader in the simulation area. But for this version, we are not installed model sim. That's we are not able to use it. So we have to by default use the iSIM. Okay, then you have to go for the VHDL language only because we are using VHDL. You can have choice of Verilog also. Then again, we'll go for the VHDL 93 pattern only. Then we'll go for the next stage. It will show you the summary of your project. So which type of project, name of the project, type of device you have selected, and after that finish. After finishing it, again it will show that blank window. As I told you previously, it will show you the blank window here. So I will go to the project and I will ask for the new source. Okay, when I go for the new source, it will ask me the source. I will go for VHDL module. In that, I will just write ALU, name of the design entity. After that, add to project and create it. Okay, so instead of creating ABC and all that, I will just take the design from my own lab manual. So I will just make it next and finish. Okay, it will generate a code which is having the blank input and output for the entity. It will not having any port information. So I will just select it all, delete it. Okay, and from my manual, I will go it. So I will just check whether my project is opening or not, because it was not opening. That's why I done all this thing. So it is still not opening with this software. There can be some problem in my laptop. Previously it was work actually. I will just open the last project that I made up right now. So in that I will add a source file here. Okay, this source file actually it is not saved. That's what it's showing the same again. So make it delete. Okay, after that I will go to my manual. In my manual I am having the ALU code. You can see that in this manual. You can see this ALU code here. Okay, the same code I will just copy paste here. Okay, by default if you take the wizard, everything will be ready for you up to this begin. Okay, for ALU also. So I will just copy it and paste it. After pasting it, you can see that entity name clearly written in the blue color. Then after that, this architecture name and the port information is shown. The ports are A, B. ALU out is the output of the ALU, and select line for the operation of the ALU. Okay, to do which operation, you have to select the select lines. In begin, you have this select with select statement, and with select statement is actually selecting the function to be executed by the ALU. So here you can see that for the ALU out, the output is A plus B when the select line status is 000. Okay, when it is 000, this select line is 000, then it is becoming A plus B. So likewise, you can have different functions in the arithmetic and logic fashion. So these are the arithmetic fashion: A plus B, A minus C. Then you are having this logical operation, ANDing, NANDing, or XOR, XNOR, or you can have multiple operations. Simplicity simulation, these simple basic operations are taken. You can have a complex operation also, gray conversion, or you can have XS3 coding, like that. You can have multiplication, division also. So for simplicity, this ALU is having these very simple operations, 5, 6 operations. After writing this code, you can always go to the check syntax. I will just click this file first. Okay. After clicking this file, this type of windows are getting invoked. Okay. After getting this, you go to the synthesis. In synthesis, you will get this check syntax. I will just right click it. When I am doing it first time, so it will default run. But when I want to make it run for all other conditions, so in that case, you have to click the run all. So now you can say that something error is coming. What type of error is coming? Actually, this code is not having any error actually. Standard logic vector line 3. I will run it for one again. Mm, It is saying that ALU underscore 4 bit is not existing, but it is already there, ALU underscore 4 bit, and it is there in the file also. I will just close it and open it once again. Actually, there is no such error in the code. Okay, I will try with the new project again. New project, ALU. VHDL. Okay, it is already done by me. That's why it is asking, do you want to or I will make the name ALU 4 bit. Okay, it is asking the same information. I will go for next. Next, I'm getting this new file, the project, new source. Okay, in new source, I will take the VHDL model, and for VHDL module, I will take the name ALU 4. Next. Okay, I will just finish it. For all this, delete. I will take the code. Okay, then I will save it. It is not understanding that values A, B, and all that. Okay. Sorry. Actually, what happened? I had copied half part of the code. That's why this problem is coming. Okay, so it was my mistake. Yeah. The libraries are actually not copied by me. That's why it is showing the problem. Yes, that's why it is not understanding what is going in this code about the entity architecture and all that, because it's not getting the package. So now it will definitely work. That's why it is showing error for each and everything. I think why it's showing either it is a problem of software or. So now you can see that syntax check is completed successfully. So I can go for the simulation. Okay. So you can see that without these libraries, it is not of use any. Then I will go for the simulation mode of this part. Okay. Again, for simulation, I had to select this file. Then iSim simulator, I had to click here. In the iSim simulator, I had to select the simulate burial model. Then run. Okay, all of you are with me.
Yes, sir.
Okay, sometimes this happens. No, sir, गड़बड़ गए कि बाकी लोग भाग जाते हैं. How many are there? Okay, 12, 11 people are there. अरे शुभम पण आलाय बाबा. शुभम वेळ काढून आलेले दिसतोय. So this is how your models ISIM window comes like previous one. Here also you are having the A, B in the 4-bit mode. Okay, so I can just select the AB here also, and here also I can here click it and just apply force constant. I will just make it 1111 plus apply. Okay, and then for B I will select
मॅन्युअलचं पेज दिसतंय सर.
yes.
मॅन्युअलचं पेज दिसत होतं.
काय म्हणतोय जोरात बोल, मला नाही ऐकू येत आहे.
ते मॅन्युअलचं पेजेस दिसत होतं म्हटलं, जे सॉफ्टवेअर आहे ते स्लाइड दिसत नव्हती.
दिसत नाहीये का?
ते दिसत नव्हती,
मुझे
आता दिसते.
दिख रहा है
Okay,
सर,
okay,
दिख रहा है.
okay. So you can see that when I apply 0, 0, 0 and 1, okay, so all 1 plus 1 will be added. I have to select the select line for the mode of operation. For selection of that, I have to check the condition of the select line. For addition, I have to have the 0, 0, 0 input for the select line. I will just make it 0, 0 for select line force 0, 0, 0. Constant, all zeros, 1, 2, 3. Apply, okay. Then I will run it. So you can see that output is coming. Okay. So why it is coming 0? Because all ones are there. Plus 1 makes it as a 10,000. Okay, 1 carry is generated and all these bits will be 0 for the ALU out. Okay, when I subtract 1 from this, it will come like this only. I will just change this one. I will make this A force constant to 1, 1, 1, 0. It will make all 4 as output. Okay, I will run this condition. Can you see that output is becoming 1, 1, 1, 1? Okay, 4 ones are coming here. So likewise, you can check the condition for all the rest of operations for ALU, arithmetic and logic. Okay, AND gate, OR gate, XOR gate also. So here you can have that combination for the radix. You can click here, unsigned decimal. So it will show you the decimal number directly for A, B, and output. Just click here. It is showing that 1 plus 14. And for this, if I click radix, okay, it is showing the 14 plus 1 equal to 15. So this simple thing can be done for the addition subtraction with the ALU. Have you understood this?
Yes, sir.
Okay, up to this, you are able to simulate a ALU. After that, we'll go for the test bench. Okay, now I am ready with the 4-bit ALU now. This 4-bit ALU can be tested with the help of test bench. Now, how to go for the test bench approach, that I will show you. In the same project, you have to click for the new source. Okay, project, new source, and in new source, you have to select the VHDL test bench. Instead of VHDL module, I will check test bench. Now I will name the test bench as a ALU test. Okay, 4. Just for changing different name, I will write it ALU test 4. So when I go to next, it will go for the showing you the architecture of the component which are going to test. So as you know, design under test, we have seen the UUT or DUT. That DUT or UUT is having this port map information that is actually shown here. So that same thing is called as a component in the test bench, because this complete project is built of two sources now. One source is of your VHDL model for the ALU, and another will be test bench for the ALU. That by default it is taking that one entity is present. That's why it is showing only one. If it is having two entities or three programs, four programs, then it is having 4 or 5 entities shown here. Out of that, you have to select basically. So by default, it is having only one. That's why it is showing only one only. After going for the next, it is showing that association for ALU 4-bit is done with the test bench in this code. When you go for the next, it will generate the code for that ALU test. Okay. So now here also, what is happening? So in this case, what we have to do actually, instead of going for this, actually this is basically simple to understand, but you don't go for this approach initially. You just go for my code, which is shown in the manual. I will just select it. By default, it is giving you the same structure, but it is not understandable at this stage. I will go to the manual first and I will show you that very simple code for the ALU test. You can see that for this, by default, that tool is actually taking up to this part, okay, up to signals and all that. You can see here, okay, you can see that up to this part, up to component, okay, this component, it is taking the same thing, signals and all that, okay, this part, entity, then architecture, then component calling, then signal generation, okay, up to this part it is as it is. After that, use of the component is also as it is. But for this part, please don't get confused. I just remove this part, okay. For removing that, I will just remove total project code, okay, for testing test bench, and then I will take the code from my manual. Oh no. It is not working actually. Switch shift. I will take Word file for that then. This is my test bench. Here you can see that in I copied it and just pasted here, okay. So now you can see that as I told you in last practical also, in that EDA playground, so we have to have the minimum condition for testing, okay. Don't go for all testing conditions. So here you can see that original entity is called, okay, ALU test is an end of ALU test. Without any port information, you are defining a ALU test entity. So this entity is basically called as a test bench entity. And because of this test bench entity, it is not having any input output ports, because it is not communicating with the outer world. It is actually working with the internal design unit. So which is that internal design unit? That internal design unit is your original ALU made by you previously. So this is what my previously made ALU that I have recently made. This is called as a component in this design. So that's why it is showing that top entity is your test bench, and in below that you are getting this hierarchy for the ALU design. After that, when I click it here, I will show uh, this entity first, okay. After the entity, architecture starts. In the architecture, you can see that component is called as a UUT. So here you can see that component ALU 4 bit, the same name should be there for the component. Whatever is there for this ALU 4 bit, that same name is called as a component. So that's why it is understanding, that software is understanding you are calling this component. After that, all the port information as it is in component. Then by default, this is actually taking the signals A, B, and select line, and for output ALU out. So you can take same name or you can take different name also, X, Y, Z. Okay, whatever name you want, you can take as a signal. So that depends on you. But by default, this wizard is taking the same name as your entity names. That's why it is showing that A, B, select line, and ALU are generated here. After that, in begin of the architecture is actually calling the component for mapping the signals. So these signals are having A, B, select line. These same signal lines are mapped to the original component. So because the original component and this component is also having the same name signals, the same names are replaced here with the help of named association. So as I told you, name association actually working like this: the old name and the new name. Okay, here it is your signal name. The signal name is given to your original entity A, then B to B, ALU out to ALU out, and select line to select line. If you want to change it, you can change it, and you can have the different name for that for your understanding. So by default, this software is also doing the work for you up to this one. After that, you just skip the part for other things, and you just add this simple statement: wait for 100 nanoseconds, because this is a process statement, and in process statement you are executing the statements in sequential manner. And when the sequential manner code is executed, it is checked for the first line. It will wait for the 100 nanosecond in the first state. Okay, if you are not using the wait statement, you have to write sensitivity list here. Okay, just like the previous practical in shift register, we have seen that select line or serial input and input data are taken as a sensitivity list in the process sensitivity. But in this case, it is not taken because wait statement is used. By using the wait statement, you are actually executing the process with the help of wait. Now after that, waiting for 100 nanosecond, you are just defining that select line should be given with 3 zeros. Okay, 3 bit 000. After that, A should be given to 4 bit 0011. Then B to 01110. Then wait for 100 nanosecond. Why to wait for 100 nanosecond? To get the output come out of the UUT or design. Okay, you are just waiting for some time to output come. Okay, then again you are changing the next set of the inputs. Yes, you can change it to anything you want for the testing. So minimum 2-3 condition you can simulate. For this, I actually have the different combination for the input output, some arithmetic and some logic function. You can see that in the simulation right now. So when you go for simulation object, just click here. Okay, and then simulate on this. After getting simulation, you just click the top entity, that is test bench. Don't click here, otherwise it will simulate your original design. But if you want to use the test bench, click on the test bench and then iSim simulator. After that, go to the simulate behavioral model and right click it and run. Again it is asking for the saving the code, because I have not saved it earlier. Some error is coming. What type of error is coming? Okay, it is saying that it is not finding the ALU test 4. So why it is coming so? ALU test 4. Okay. I am never using the ALU test 4 actually, but still it is asking for that ALU test 4. I know where it is mentioned actually. ALU test, okay, and entity, then ALU test use, behavior, okay. So, okay, I will change the name of this main entry test bench architecture to ALU test because of behavioral, same name of behavioral, it may have the problem. ALU test 4 and then end of ALU test 4. It is not required. We will try with this. First, I will check for the syntax checking. No syntax problem. I will first run the ALU 4, that original ALU, because it is not showing here right now. That's why I'm doing that. It is actually gone because of change of the name. Still, now I will do fit for this. Okay, now I'll run this one. Yes. Now you can see that instead of giving inputs to A, B, and select line, it is actually taking the input given by me in the test bench. So for getting all the conditions, you can click on this view all. You can see that in very first condition, all the inputs are 0, 0, 0. Okay, by default in the program, it is not mentioned earlier that you can see that here in this condition. Okay, before this one, before this condition, wait for 100 nanosecond. I told that it is not doing anything for the 100 nanosecond. First 100 nanosecond, the input is not changing. That's why for 100 nanosecond, it is showing all 0, 0, 0. After 100 nanosecond, the given set is applied. You can say that after 100 nanosecond, what is happening? Select line is made 0, then A is made 1, 1, and B is made 1, 1, 0, 1, 1, 0. You can see that here A is made 0, 1, 1, and B is made 0, 1, 1, 0. Okay, and after that, the select line setter is 0. It is doing the addition function. So you can see that here, if I change the radix, simply by changing the radix to unsigned, this will work for the addition subtraction only, or arithmetic function only. So you can see that it is showing me the addition. Sorry, hexadecimal. I will choose it for radix of unsigned. You can see that 6 plus 3 is coming 9 here. Okay, then here it is mode is changed with the select line. It is coming to subtraction. So 11 minus 6, it is coming to 5. Okay, it will be more easy if you make the radish change, and this is how your test bench works. So by using this simple statement instead of using the wizard statements, you can able to simulate the design with the help of test bench. Only 5, 6 condition I mentioned. So what are your minimum conditions are required to test that design that you can give? For example, of AND gate, you can use only two conditions for testing an AND gate. Means for testing the AND gate, minimum required condition is that all the inputs are 1. When all the inputs are 1, output should be 1 only for the AND gate. And when any one of the input becomes 0, at that condition AND gate should get the output 0. With this two condition only, you can check the AND gate, which is requiring actually 4 conditions for testing. So not all 4 conditions should be tested for the design. You can have the minimum check of some required condition or some essential condition that you can do for that particular design for testing with the help of test bench. Test bench is the fastest way to automate the testing procedure. If you are having, say, bulkier design having hundreds of gates or hundreds of components in the design, so it is possible to run this test with the help of automated file. And actually in the industry, people are actually in very high capacity computers which are running the code for 2-3 days at least, okay, for the bigger designs. In the previous days, actually it was taking 10-15 days, but now the capacity of the processor are increased and they are using the GPUs also for the processing. That's why the work is finished in some hours or days. But it is very bulky for the processor to finish this work, because initially they have to make the synthesis, and this synthesis process is actually complicated. If you get the good synthesis out of the design, then and then you will get the right design with the high speed. So that is what the things I want to tell for today. So only one thing left for you, so that I will show you now. Again, if possible, it is opening the previous one. No, it is closing again. I'll open it again. Okay, it is opening previous project. In this project, if I add something or I'll take a new file, basically new source, VHDL module, then name of that module, say XOR gate, XOR gate. Then I will take, say, input A, B, and C as the output. Okay, then finish it. I will get this thing in XOR gate entity and architecture. I will just write C signal assignments equal to A X or B. So this is not consensus. You can write the capital XOR also. That is the advantage of this software. You can write a capital XOR also or small XOR also. So by using this statement, you are able to have this. I will just remove this design because it is not giving access to this design. Okay, now you can see that my XOR gate is showing this all other windows. So now I will go for the synthesis directly. Actually, what synthesis is doing, that I am going to show you. Okay, the message is shown that process synthesis XST is completed. XST is the Xilinx synthesis tool. After completion of this, you can see that in the Xilinx synthesis, you are having these options. Okay, I think it is visible for you. Yes, now you can see that in under the synthesis, you are getting this check syntax also. Okay, and here you will find that view RTL schematic. So when I click it, view RTL schematic, it will actually opening the RTL schematic for this. So whether it is working or not, I don't know. Just click it. I will take this one, this option. Actually, it was asking for the wizard. I will not take yeah. Now you can see that whatever design I have done as a entity, A, B input and output is C. So that same black box is coming here. Many times I have called it as a black box. So you can see that this black box is coming here. So when I click this black box in the RTL schematic, it is showing the internal of that black box. Can you see that? Here it is showing you that internals. Okay, and again if I click it, na internal of that also. So here it is showing you the different internal blocks of that black box. So here it is showing the internals of XOR gate. So here you can see that it is implemented with the help of some uh, AND gates, okay, with inverted input. Okay, and it is going to the next one, which is a OR gate. So when you are having the bubble input AND gate and this OR gate, it is working or resembling XOR gate. So this is getting for the simple XOR gate. Okay, the RTL schematic. So this was the register transfer level for particular device. So if you go for the bigger designs like ALU, it is showing you the internal details of that. I will just try for the ALU if it is possible. Oh no, software is not supporting actually. So I think you got the idea. You just do it with ALU, and when you go for the clicking the ALU, it will show you the ALU details also, RTL schematic for the ALU. So you can see it. There is nothing great to observe it. Actually, a lot of components are shown. It is just for your viewing experience. What is there inside the design you have designed? Okay, inside the FPGA. So you should know what is happening with the FPGA or what is happening with the synthesis tool. That's why I'm showing you. That is sufficient for that AND gate also. So you can do it with your ALU design, and after that you do the submissions for this ALU shift register and rest of the two practicals, keypad and LCD controller, that I will explain in the coming practical. Okay. So for I think next week, if I get the time, I will explain the micromin software first. And because in the manual we are having all these codes ready with you uh, for this LCD controller. Okay, so this is the LCD controller. Again, it will take an half an hour for explanation, and this keypad controller. Okay, this will take 1 hour for the explanation. So meanwhile, you can take this code for simulation. It will work nicely, but it is not possible to get it done with the simulation tool itself only. Okay, because for LCD you will get some signals on the data lines only, but if you have real LCD interface with the hardware, then and then you will able to see that message on the LCD screen. Okay, again for keyboard also, if you have pressing facility, keypad pressing facility only on the key, then and then you can observe what is happening. So these are actually we can have this simulation only for these practicals in the coming days. But before that, we'll start with the microwind software for the uh, layout designs. And if I get the time after that, next week, I will explain the keypad and LCD also. So I will try to explain this in this month only. We will be able to finish all these assignments and all the theory parts in the October month only. So actually, this is our actually where we all are all teachers are actually trying to finish the syllabus in this month only, so that you can have your other activities and project completion in time. I think all of you got this manual. All of you got the manual, no?
हाँ सर मिल गया.
Yes, yes. So you can start with this. I think Shashi has already downloaded and started using the software. He is the only one person who has tried for the Xilinx software, and because of him also, I have got the link and I have downloaded it. That is actually great effort by